Assalamu alaikum. Welcome to another session of Data Structures and Algorithms. My name is Dr. Bilal Wajid. So lecture 27 is actually going to complete our linked list, and inshallah in lecture 28 we're going to start another topic. So lecture 23 we introduced our linked list, where we talked about linked list, double linked list and circular linked list. 24 talked about create, 25 talked about traverse, 26 talked about add. And this lecture we're going to finish all the basic functions which are part of our linked list, so that are create, traverse, add, length and delete. So any particular element of the linked list, we are defining it using a structure. So a structure element, it contains a value and a pointer that can point to the next element. We have two global variables which are very useful. One is the length, right? Because we are deleting, so it helps to have length as a global variable. You can just, whenever you delete a particular element of the list, you can just decrease it by one. And the other all important variable is the start, which points to the first element of our linked list. Because this is our global definition, so initially start has been assigned to null and length has been assigned to 0. Now, because length is a global variable, the function length is extremely simple. You just return whatever the value is stored in length. Okay? Now, as far as delete function is concerned, while you write or program delete, you have to consider 4 options. That is, the first case is, what do you do when the list is empty? And what do you do when the list is filled? When the list is filled, you have 3 options. What are you supposed to do when you want to delete the first element, or delete any particular element, or you traverse through the entire list and you don't find the node that you want to delete. In other words, you don't delete. Okay, so we're going to explain you now how to program all these 4 conditions. Now, in the first cases, again, I've kept this delete function void, so you don't really need to return anything, and I'm only asking for the value x that helps us search for the particular element that we want to delete and hence delete it. Okay, the first thing you should see that the delete function, I've not named it as delete, I've actually named it as del. The reason for that is delete is actually a reserved word which is used to delete pointers, okay, or dynamic memory allocations. So that's why you can't really use, I would not recommend you to use the word delete for a delete function. Just use the word del or something similar. Okay, now when the list is empty, you can check it by 2 conditions. Either start would be equal to null or the length will be equal to 0. In either case, if the length is equal to 0 or if start is equal to null, you can simply say, well, the list is empty, so there's really nothing for us to delete. Right? So that resolves our first condition. The second is, what happens if the list is filled? Well, then the else block is invoked. And within the else block, we have to figure out how to delete the first node, delete any particular node, and what you do when you don't find any element or node with the value x. Again, I'm using the word node and element interchangeably. Okay, so every component of the linked list, I'm either saying it's an element or I'm just using the word node. Okay, so when the list is filled, right, you actually need for this particular function not 1 but 2 pointers. The first pointer is going to store the current location, and the other pointer titled previous will store the component of the list previous to the current list. Okay, initially current and start are both will be initialized to the first location of the linked list. Okay, so the all important loop here is this while loop. What this loop says is continue up until the next element is not null. So you continue up until there are newer and new elements, and you actually stop when you reach the last element, in which case current next will be equal to null. And you continue as long as there is another location and the current location is not the one that you have to delete. Okay, in other words, because the value is not the same as x. Okay, so this is your all important condition, right? Because this tells you, number one, you continue up until there is more elements in the list, and you continue as long as you are at the node which you don't have to delete. Okay, so let's consider the first case where you want to delete the first node, in which case the value is the same as the value you've given it. Okay, and if this is the case, as soon as you run this while loop, right, because current is pointing to the first location and the value, well, this will become false because the value is the same as x, right? So current's value is not equal to x. No, this is false. So hence, because current value is the same as the first value that you want to delete, you're not going to execute this loop. Rather, you're going to come one step beyond it. When you come one step below, you have to check what was the reason this while loop shut down. Was it this condition? Did you reach the end of the list, or did you find the element you had to delete? Did you find the component or the node of the list that you wanted to delete? So this is where you check it. Okay, if this is the reason that current value is the same as the element you want to delete, you check, is it the first element or is it any other element? If it is the first element, right, if current is pointing to start, then what you do, you actually update start. So initially start is pointing to this node and this is what you want to delete. So simple, you just make start point to the second element. Okay, so start is now pointing to current's next. So start is no more pointing to this location, start is actually pointing to the second location. And then once start is pointing to the second location, you can simply delete this. You can write delete current and you can just delete this whole thing. And because now you've deleted an element of the linked list, there are less number of elements in the list, hence length has been assigned as length -1, right? It's that easy. Now, what happens, let's consider what happens when you cannot find the node. Okay, in this case, when you start executing the while loop, it is this condition which is responsible for stopping it. In other words, you continue up until you reach the end. Okay, so what happens here, let's consider this. Initially, current and previous are pointing to the first node, right, which is the first element, right? Then you update current, so it points to the next location. So current has been assigned as current next. Now you check the condition, well, current's next is not equal to null, so previous is now the same as current, right? And then current has been updated, so it points to the next location. Now you again check the while loop. Because current's next is null, the while loop ends. Okay, the while loop ends. Now once the while loop ends, you have to check which of the two conditions did work. Because it's not this condition, it's this condition. You simply go to else and you say, well, we could not find the node with this value, so nothing to delete. Okay, so now the last option is, how do you delete any middle node? Again, you look at this while condition, right? Because in this particular example, I am assuming that this node has the value x that we want to delete. Okay, so in this condition, because current next is not equal to null and this value is not the same as the one that we are looking for, you just, previous is pointing the same as current, and then now you're going to update current, so it points here. Okay, so current has been assigned as current next, so now it points here. Now when you go back to the while loop, you'd see, well, current's next is not equal to null, that is true, but this becomes false. When this becomes false, why it becomes false? Because you have found the node which contains the same value as the one that you want to delete. Okay, so you're going to exit this while loop. Okay, so because current's value is the same as that of x, right, what you do is, now because you have previous, you say previous is next is not pointing here. Remember, in the previous case, previous is next is pointing to this location. Now you want to bypass this location, so it doesn't point here, rather it points here. And how you do that? You simply say previous is next is pointing to current next. Okay, so that's what you do. You say previous is next now is no more pointing here, it's actually pointing to current next, so it actually points here. So once this points here, you can delete this guy, right? You can delete this guy, and because now you've deleted an element and the list is fine, you can start from here, you go here, then you go here, and then you end up here, right? Because you've deleted a guy, you need to reduce the number, so you need to reduce the length. Okay, so all these things together make our delete function. Here is my program for lectures 24 and 27. Okay, these are the basic element. This is our global definition. Here is the create function, right? It tells here, it checks if the list is not empty, if the length is not equal to 0, you should try the add function. In the examples, in the program that I showed you in the lecture, I just used if, but here I'm using the try, throw and catch block. This is the add function. Again, I'm using the try, throw and catch. This is the traverse. This is the delete. Here I'm not using it. So you don't have to use the try, throw and catch. You can just use if else statements. That also works fine. And here is my choice function, which basically helps me, you have to ask the user, what do you want? Do you want to create or add, delete, length? You want to find the length of our linked list, or you want to traverse, right? And this is my while loop. This is an actually excellent way to continue doing this over and over again up until the user says, I don't want to continue. Okay, when you run this function, right, it says create, add, delete, length. Let me just be a little mischievous here, and let's say I want to add something. Because the list is empty, it says you shouldn't be calling out the add function, you should be calling out the create function. So do you want to continue? Yes, I want to continue. So let me just do it nicely here. Let me create, and I want to input a value, let's say 1. And you want to continue? Yes. And what is the length? The length is 1 because I just put in the value 1. Do you want to continue? Yes. Let me just add a bunch of values quickly, and let me add 100, and then let me add 1000, and let me look at the length. The length is 4, and let me look at the traversal. Well, these are my current linked lists. Now let's start deleting things one by one. Okay, do you want to continue? Yes. This time I want to delete, so I'm using the option 3, which corresponds to delete. Okay, now let me try deleting a value which is not present in the list. So let me just try deleting the value 99. Okay, it actually says here, well, node with value 99 is not found, has nothing to delete. Okay, so let's traverse. You can see nothing got deleted. So let me try a different function this time. How about deleting, let's say, this guy 10. Okay, so I put in 10 and I traverse, and we can see now we have 100 and 1000. 10 got deleted. Okay, let me now try to delete the first guy. So I want to delete value 1. I run the traverse function. Notice that 1 is deleted. It only has 100 and 1000. And if I check the length is 2, right? And I can continue doing that, and I can actually delete everything, and then I can just I can delete even 100, and then I can also delete, let's say, 1000. And then I can check the length. The length is actually 0, right? This way I've actually deleted everything. Okay, so again, try these codes, try writing these codes yourself. If you like my lectures, hit the thumbs up and subscribe and hit the bell icon to get notified for the next lectures. Okay, up until next time, thank you very much. Bye bye.